There is an experiment called quantum suicide. Scientists ask you to pull the trigger while aiming a gun at your own head, but whether the gun fires or not depends on a quantum state. If parallel universes exist, then no matter how many times you pull the trigger, you will never die, because among countless parallel universes, there is always one universe in which the gun does not fire, and your consciousness will only continue in that universe where you survive. What does this mean? It means that in your subjective experience, you will never experience death. Even crazier, in 2022, the Nobel Prize already used quantum entanglement to prove all this. When Schrodinger's proposed this theory, the very first sentence he said was, "What I'm about to say will make you think I'm crazy." But now it seems, the one that's crazy isn't him, it's the universe itself. Why is this universe so insane? The answer begins on a late night in 1957. That year, a 27-year-old American named Everett wrote down a world-shocking theory. In his dorm room at Princeton University, he said the wave function never collapses. Every quantum measurement splits the entire universe in two. When he told this idea to his advisor, the advisor fell silent for 10 full minutes, because this meant that at this very moment, while you are reading these words, in countless other universes, there are countless versions of you doing completely different things. But how does this actually work? To understand that, we have to talk about quantum mechanics, the thing that even drove Einstein mad. In the early 20th century, when physicists began exploring the microscopic world inside atoms, they discovered a chilling fact. In the quantum world, everything is uncertain before being observed. An electron can exist in multiple positions at the same time. This state is called quantum superposition. Even stranger, only when you observe it does it choose a definite position. It's like a coin spinning in the air. It is both heads and tails at the same time. Only at the instant it lands does it become one or the other. Schrodinger's was extremely unhappy about this. In 1935, he designed that famous thought experiment. He locked a cat inside a box. Inside the box was a mechanism. Whether it releases poison gas depends on whether a radioactive atom decays. And before being observed, that atom has both decayed and not decayed, existing in a superposition. So here's the question: is the cat inside the box dead or alive? According to the Copenhagen interpretation, before you open the box and observe, the cat is both dead and alive. Schrodinger's used this absurd example to mock the mainstream interpretation of quantum mechanics at the time. But unexpectedly, he accidentally touched upon the deepest truth of the universe. Einstein immediately stood up in opposition and said his famous line, "God does not play dice." He firmly believed the world should be deterministic, that such vague superpositions should not exist. Unfortunately, experiments kept proving Einstein wrong, again and again. Quantum mechanics may look insane, but its predictions are unbelievably accurate, with errors so small they can be ignored. Without quantum mechanics, there would be no modern computers, smartphones, or GPS. Even the screen you're watching this video on relies on principles of quantum mechanics. So if quantum mechanics works so well, why do scientists still argue about it? Because it leaves behind one enormous mystery. Why does observation cause wave function collapse? What exactly counts as observation? What role does consciousness play in all this? These questions haunted physicists for decades, until Everett proposed his many worlds interpretation. Everett said, "There is no such thing as wave function collapse. When you observe the cat, the universe doesn't choose whether the cat is dead or alive. Instead, the universe splits into two. In one universe the cat is alive. In the other universe the cat is dead. Your consciousness splits as well. In one universe, you see a living cat. In the other universe you see a dead cat." Sounds crazy, right? But this theory solves the most painful problem in quantum mechanics. It doesn't require a mysterious observer effect. It doesn't give consciousness a special status. The wave function simply evolves smoothly according to Schrodinger's equation. Whenever a particle faces multiple possibilities, the universe splits. All possibilities are realized in different branches of the universe. Imagine every second, trillions of atoms in your body are making quantum decisions. Every decision could cause the universe to split. This means, how many parallel universes does the universe split into every second? The answer is, infinitely many. But then another question arises. If the universe keeps splitting, why don't we ever feel it? Why do the outcomes we see always feel definite, instead of a blurry superposition? In the 1970s, physicists found the answer, a theory called decoherence. Simply put, when a quantum system interacts with its surrounding environment, those different possibilities get locked into their separate branch universes and can no longer interfere with each other, like two parallel lines that never intersect. This explains why we live in a world built from quantum mechanics, yet never observe those bizarre quantum superposition effects, and the 2022 Nobel Prize in Physics provided strong support for the many worlds interpretation. French scientist Elaine Aspect, American scientist John Clauser, and Austrian scientist Anton Zeilinger experimentally verified the existence of quantum entanglement and proved that Bell's inequality is violated. What does this mean? It means Einstein was wrong. The universe really does play dice, and it plays them in an even crazier way than we imagined. Quantum entanglement shows that two particles can instantly affect each other, no matter how far apart they are. This ghostly action at a distance is exactly what the many worlds interpretation predicts. Even more astonishing, the emergence of quantum computers is almost direct evidence for the existence of parallel universes. Traditional computers calculate using zeros and ones. Quantum computers use superposition, allowing a qubit to be both 0 and 1 at the same time. If you have 300 qubits, they can perform 2 to the power of 300 calculations simultaneously. How big is that number? Larger than the total number of atoms in the observable universe. Oxford physicist David Deutsch said it bluntly. Where are these calculations happening? If not in parallel universes, then where else? So how many parallel universes are there? The answer may shock you. Infinitely many. And in every parallel universe, there is a copy of you. At this very moment in some universe, you may not have clicked on this video. In another universe, you might be landing on Mars. In a third universe, you might already be a billionaire. And in yet another universe, you might not exist at all, because your parents never met. Every tiny quantum event creates a new branch universe. The branches of this cosmic tree are far more vast than we can imagine. But the story isn't over yet. In 2017, scientists at Oak Ridge National Laboratory in Tennessee were conducting what seemed like a boring experiment. They fired powerful neutron beams at a wall. According to the laws of physics, no neutron should be able to pass through that wall. But something strange happened. They discovered a mysterious discrepancy in neutron lifetimes. Inside particle accelerators, neutrons survive an average of 14 minutes and 48 seconds. But in laboratory bottles, neutrons decayed 10 seconds earlier. This 10-second difference cannot be explained by any current physical theory, unless some neutrons escaped into another parallel universe. Scientists proposed an even crazier theory, the mirror universe. They believe there may exist a mirror world almost identical to our own universe, with mirror atoms, mirror molecules, and possibly even mirror Earth and mirror humans. This mirror universe exists right next to us, separated by an unimaginably tiny distance, perhaps only 1/1,000,000,000 of a centimeter. And neutrons, as special particles, may be able to jump between these two universes. If this theory is true, then scientists at Oak Ridge may have unknowingly opened the very first door to a parallel universe. Even more intriguing is the mystery of dark matter. We all know the universe contains massive amounts of invisible matter. It emits no light and reflects none, yet it makes up 85% of the universe's total matter. Scientists searched for decades and still don't know what dark matter is. Now, one theory suggests dark matter may not exist in our universe at all. It could originate from the mirror universe. Matter from the mirror universe influences the motion of galaxies in our universe through gravity. This explains why we can feel the presence of dark matter, but can never observe it directly. If this theory is correct, then our universe is like a sheet of paper, and the mirror universe is another sheet. The two sheets lie almost on top of each other, yet never overlap. At this point, we must return to the experiment mentioned at the beginning. Quantum suicide. If the many worlds interpretation is true, then in theory, you will indeed never experience your own death, because in every branch universe where you die, your consciousness disappears, and your subjective experience continues. Only in the branches where you survive, no matter how small the probability, there will always be one branch universe where you remain alive. This is called quantum immortality. But please note, this is only your subjective experience. In all other branch universes, your family and friends will truly experience your death and mourn you. So please, never try this experiment. Everett himself is said to have been a firm believer in quantum immortality. Although he never explicitly wrote this in his papers, his family and colleagues recalled that Everett believed his many worlds theory granted him a form of immortality. Ironically, in 1982, Everett died suddenly of a heart attack at age 51, but according to his own theory, In some parallel universes, he is still alive, perhaps still studying quantum mechanics. It is a sad yet thought-provoking ending. A man who devoted his life to parallel universes ultimately became part of them. The parallel universe theory also solves a puzzle that has haunted science fiction fans for decades. The grandfather paradox. Suppose you travel back in time and prevent your grandparents from meeting. Then your father would never be born, and you would not exist. But if you don't exist, who went back in time to stop your grandparents from meeting? It's a logical loop. But if the parallel universe theory is correct, this paradox disappears. When you travel to the past, you actually enter a parallel universe. Changing history there does not affect the universe you originally came from. You will still be born and grow up in your original universe. Then invent a time machine. So time travel is possible. You're just not changing your own past. You're creating a new parallel universe. Now imagine every choice you face in life. Should you brush your teeth first or wash your face when you wake up? What should you eat for lunch? Should you message the person you like? Every choice creates a new branch of the universe. In one universe, you gather the courage to confess, and the two of you end up together. In another universe, you stay silent and miss that person. In a third universe, you meet in a completely different way. Countless parallel universes, countless versions of you, each walking a different life path. Some versions of you succeed, some fail, some are happy, some suffer, but every version of you exists just as real. What does this mean? It means every decision you regret. In some parallel universe, another version of you made the right choice. Every opportunity you missed was firmly grasped in another universe. The person you once loved but couldn't have, in some universe, is spending a beautiful night with you. This is both a cruel and gentle truth. All of our regrets are redeemed in some parallel universe, but at the same time, all of our successes may turn into failures in other universes. But this shouldn't pull us into nihilism. On the contrary, the parallel universe theory tells us every present moment is crucial, because the choice you make right now is creating a brand new branch universe, a unique universe that belongs to you. In this universe, you are the only protagonist, though there may be countless parallel versions of you. The you making this choice right now is absolutely unique across the entire multiverse. The parallel universe theory is still just a theory. At present, there is no direct experimental evidence that can fully confirm it, but more and more clues are pointing in the same direction. Our universe may truly be just one among countless universes. Perhaps one day in the future, humanity will invent more advanced observation technologies and truly open the door to parallel universes. At that moment, we might see, in another universe, another you looking back at us with the same look of surprise. And now, when you put down your phone and lift your head, the universe has split again. In one branch, you decide to follow this account and keep learning. In another branch, you swipe past this video. But in this universe, at this very moment, you have already learned the most outrageous truth about parallel universes. Remember, among countless parallel universes, only the version of you in this universe finished watching this video.